Hi students, have a nice day. In this section, we are entering into the new topic, alkynes. In the last several sessions, we discussed about the alkenes, their properties, then alkenes preparation and properties. What are alkynes? Alkynes, the hydrocarbon which contains carbon-carbon triple bond. Okay, carbon-carbon triple bond present in the hydrocarbon, it is called alkynes. And alkenes have a general formula CnH2n minus 2. In the case of alkane, CnH2n plus 2. In the case of alkene, CnH2n, okay, plus 2 is eliminated. In alkynes, CnH2n minus 2, okay, plus 2, no 2, that is 0, then minus 2, okay, that is the order. And alkenes are very important compounds in many preparations, polymerization, etc. Okay, let's discuss the nomenclature of alkanes. You know how to name the hydrocarbons or alkynes. In common name, alkanes are derivative of acetylene. Okay, in common name, alkanes are derivative of acetylene. Nomenclature. So we can make it two columns. One column is common name and the second column is IUPAC name. First molecule, CH triple bond CH, acetylene. Okay, acetylene. CH triple bond CH is known as acetylene. And the IUPAC name is ethyl. Two carbon atom. So H for alkynes, YNE. Okay. The next is CH3, C triple bond CH. It's a derivative of acetylene. So it is methyl acetylene. Methyl acetylene. What is the IUPAC name? Propyl. Propyl is the IUPAC name. Another is CH3, CH2, C triple bond CH. Next member, ethyl, propyl, next member. It is ethyl acetylene. Ethyl acetylene. And the IUPAC name is but1-ene. Because it has an isomer CH3, C triple bond C, CH3. It is dimethyl acetylene. Dimethyl acetylene. What is its IUPAC name? but2-ene. Okay, 1, 2, 3, 4. but2-ene. Yes. Then another one. CH3, CH, CH3, C triple bond CH. It is isopropyl group. So isopropyl acetylene. Isopropyl acetylene. What is common name? In common name, we give the priority. If only one C triple bond C, we give the priority to alkyne group 1, 2, 3, 4. What is this IUPAC name? 3-methyl but1-ene. 3-methyl but1-ene. Okay, so that's about the naming. And you know that if two triple bond is present in the hydrocarbon, we write the ene. Okay, I give an example. If two double bonds are present in, we write diene. So CH triple bond C, CH2, C triple bond CH. Two triple bonds are there. So starting from any position 1, 2, 3, 4, 5. Okay. 1 and 4th position. First position and 4th position. Triple bond. What is the IUPAC name of this compound? Penta 1,4 diene. Okay, penta 1,4 diene. So these are the common rules for naming the alkynes. Next is isomerism. You know that what are isomers? Isomers have same molecular formula but different structures are called isomers. And the phenomenon is known as isomerism. Okay, the phenomenon is known as isomerism. Alkyne shows or alkyne exhibits chain isomerism as well as position isomerism. Okay, alkynes mainly exhibit chain isomerism and position isomerism. And chain isomerism exhibited from the higher alkynes, not in the lower alkynes. Okay, let's discuss some examples. First one, CH3, CH2, C triple bond CH. Position isomerism, it is CH3, C triple bond C, CH3. This one is butyl 1 in. 1, 2, 3, 4. Butyl 1 in. This is butyl 2 in. Sorry, in. Butyl 2 in. Okay. Another one. CH3, CH2, CH2, C triple bond CH. Then CH3, CH2, C triple bond C, CH3. What is it? It's pent 1 in. Pent 1 in. What about this? 1, 2, 3, 4, 5. What about this? It is pent 2 in. Pent 2 in. Okay. Pent 2 in. Number from any direction. 1, 2, 3, 4, 5. The position is second position. 1, 2, 3, 4. This numbering is wrong. Okay, first of all, you try to number the chain from any direction and apply lowest sum rule or locant rule. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 is wrong numbering. So pent 2 in. Next is chain isomerism. This is position isomerism. Okay, butyl, it doesn't have any position isomerism. Okay, butyl doesn't have any position. Butane doesn't have any chain isomerism. Okay, but pentane have chain isomerism. This CH3 comes in this place and one of the hydrogen is replaces. What we get? This CH to become CH3. the CH3 migrated to the second carbon atom. So CH, CH3, C triple bond CH. Okay. So these two are pentamer 1 in and 3-methyl butane 1 in. These two are chain isomers. Okay, remember that the position is doesn't change. The position doesn't change. And these two are also chain isomers because it has the formula C5. Both having the formula C5 and H8. Just count it. 3 plus 2, 5 plus 2, 7 plus 1, 8. These two have general formula and different chain. These two have, okay. These two have also general formula same. But the structure is different. So if the structure is different, the isomerism is known as chain isomerism. The chain different, chain isomerism. Position of triple bond is different. It is called a position isomerism. Clear? Yes. Then we move to the structure of the alkynes. Structure of the alkynes. This is already studied in the 4th chapter. Anyway, we just discuss what is the structure of alkynes. Alkanes have linear structure. Okay, alkanes have linear structure. And the carbon atom, the alkyne carbon atoms are sp hybridized. Okay, let's discuss the hybridization and the structure. In alkynes, the hybridization is sp hybridization. Carbon atom is sp hybridized. sp hybridized. As you know that sp hybridized carbon atom, carbon, then sp hybridization. A carbon-carbon sigma bond is forming. Carbon-carbon sigma bonds are formed. Then two hydrogen. First of all, we can explain ethyl C2H2. C2H2. Then two hydrogen atoms overlap. So we get CH sigma bond, CC sigma bond, CH sigma bond. And in sp hybridization, two unhybridized orbitals, p orbitals are there. Two unhybridized p orbitals are there. P, y and px. P, y and px. Usually z orbital is undergoing hybridization because z axis is an internuclear axis. Okay, then what happens? These p orbitals also contains electron. And the sidewise overlapping of py, py and px, px. Okay, the sidewise overlapping. That's why I make a different shape. This is one overlapping forms one pi bonds. And px, px sidewise overlap gets another pi bonds. So what is the shape of alkyne or what is the shape of ethyne? It is linear. In some textbook it is given cylindrical because around the sigma bond two pi bonds are there. Two pi electron clouds. That's why in some textbook it is given cylindrical structure. So alkanes have linear structure, bond angle is 180 degree. Okay, bond angle is 180 degree. You remember that one sigma bond between the carbon atom and two pi bonds between the carbon atom. That's the structure of alkynes. Okay? Yes. Next we discuss the preparation of alkynes. Okay, preparation of alkyne. Only few methods to prepare the alkynes. First of all, we prepare from the calcium carbide. Okay, calcium carbide. So we move to the preparation of alkyne structure. You remember that it is a linear structure. One sigma bond and two pi bonds between the carbon atom. The other CH sigma bond. Bond length is 132 picometer. All these things we discussed in the chapter 4. Next we discuss the preparation of alkynes. First from calcium carbide, second from vicinal dihalides. Okay, and some other methods are there, we will discuss. First of all, from calcium carbide, preparation of alkynes. Preparation of alkynes. First from calcium carbide. Calcium carbide. CaC2. Okay, CaC2 is calcium carbide. And this calcium carbide is hydrolyzed. H2. 2H2. That gives CH triple bond CH. Ethyne plus calcium hydroxide. And this calcium carbide is prepared from quicklime and coke. Quicklime and coke is heated, we get calcium carbide. Okay, so just understand that how calcium carbide is prepared. Calcium carbonate is heated, we get calcium oxide plus carbon dioxide. And this calcium oxide is heated with the coke. Coke means carbon. Okay, so calcium oxide heated with the coke, we get calcium carbide plus carbon monoxide. It is separated, then this calcium carbide is taken and it's moistured. Okay, water is added. So calcium carbide decomposes, gives ethyne and calcium hydroxide. A very simple preparation. So calcium carbide is treated with the water or moisture, we get ethyne and calcium hydroxide. That's the first method. And second one is from vicinal dihalides. You know that what is vicinal dihalide? The halides, the halogen atoms are on the adjacent carbon atom. Okay, halogen atoms are on the adjacent carbon atom, which is called vicinal dihalides. Vicinal dihalides is heated with alcoholic potassium hydroxide. Okay, alcoholic potassium hydroxide. We get haloalkenes. Okay, vicinal dihalide gives haloalkene. This intermediate is again treated with sodamide, NaNH2. We get alkynes. Okay, so let's discuss the second preparation. The second preparation is from vicinal dihalides. And you know that what is Vic? Vic means vicinal. In organic chemistry, VIC, vicinal. Okay. And the vicinal dihalides we taken dibromides. Okay, 1,2 dibromoethane. First of all, it is heated with alcoholic KOH. Okay, heat with the alcoholic KOH. Delta symbol means heating. This potassium takes one bromine atom. So minus KBr. Minus means eliminated. Okay. Or you can write there. Then OH and the beta hydrogen is eliminated as H2. This is alpha, beta. Or in the reverse order it is correct, alpha, beta. So suppose this bromine takes the potassium and OH takes the H from the next carbon atom. We get C double bond C, H, then Br, H. One of the hydrogen removes as water. Okay. Then this one is treated with the sodium amide NaNH2. NaNH2. Sodium takes. Okay, this is sodium. Sodium takes bromine. So minus NaBr. Okay, sodium takes bromine minus NaBr. And the NH2 group take adjacent hydrogen atom. The hydrogen atom present in the adjacent carbon atom. So what we get? C triple bond C H. This bromine taken by sodium and hydrogen. One of the hydrogen is taken by NH2 group. So what we get? Plus NaBr plus NH3. Or you can write here minus NaBr minus NH3. Okay, it's under the arrow we write minus. That means removal. D hydrohalogenation. Okay, here halogen and hydrogen is removed. So dehydrohalogenation. Again it will undergo dehydrohalogenation and we get alkynes. Okay, this is another method to prepare the alkynes. Then, in the case of higher alkyne preparation, okay, instead of one alkyl group present here, we get higher alkynes. Okay, I will explain one example. CH3, CH, Br, C, H, H. Okay. First of all, we treated with the alcoholic KOH. Okay, minus KBr minus H2. I write here. Here I write. What happens? Sorry, here it is bromine, dihalide. One of the bromine is taken by potassium. Then we get CH3. CBr double bond C H. Are you clear? Then it is heated with a sodium amide. We treated with or heated with a sodium amide. What we get? This bromine and one of the hydrogen removes CH3 C triple bond CH. In our textbook, only the preparation of ethine is given. But you understand that we can prepare higher alkynes. Okay. The next method is from the alkyne itself we can prepare from the ethine or from the other alkynes, terminal alkynes. That's a very important thing. From terminal alkanes we can prepare higher alkynes. Okay, I will explain one example. The third method is from a sodium alkanide, that is the terminal alkynes treated with a sodium amide, we get sodium alkanide, and this sodium alkanide is treated with alkyl halides. So in some textbook the preparation is given under the heading from alkyl halide. Okay, from alkyl halide. I will explain one example. CH3, CH2, Br. Okay, plus sodium Na plus C minus CH3. It is sodium propanide. Sodium propanide. And it is obtained from, how it is prepared means, I just write here, CH3, C triple bond CH plus sodium amide. Sodium amide. We get CH3, C triple bond C minus Na plus. Sodium propanide plus NH3. Okay, plus NH3. So from ethyl, that's why I already told you, from alkynes we prepare higher alkynes. So we take one terminal alkyl which is treated with a sodium amide, we get sodium alkanide. Here propyne, that's why we can write the sodium propanide. This sodium propanide is treated with the alkyl halides. Okay, alkyl chlorides or alkyl bromides. Anyway, it is from the alkyl halide. And what happens means the bromine and the sodium combines. We get, okay, just attach, we get CH3, CH2, then C, triple bond C, CH3. It is a higher alkyne. Okay, it is a higher alkyne. So from alkyne and alkyl halides we can prepare higher alkynes. Clear? Okay, next we discuss the properties of alkynes. First of all, physical properties. The same trend in the alkenes and alkynes. Okay, alkynes shows the same trend in the alkanes and alkenes. First three members are gases. Next 8 members are liquids. And higher members are solids. That's very important thing. Okay. And similarly the melting point and boiling point. Molecular mass increases, the boiling point also increases. Okay, molecular mass increases, boiling point increases. Branching takes place, boiling point decreases. So that's are the different physical properties. Then next is chemical properties. First chemical property is acidic character. Okay, first chemical property of alkyne is acidic character. What is acidic character? The compounds which furnishes H plus. Okay, or the compounds which react with the bases are called acids. The substance which react with the bases are called acids. So here alkynes, especially terminal alkynes. So terminal alkynes contains hydrogen, and these terminal alkynes react with the strong bases such as sodium amide, and also alkynes react with the metallic sodium. So reaction of metallic sodium and with the strong base sodium amide reveals that alkanes have acidic character. Alkanes are in acidic nature. So let's discuss how the alkynes are in the acidic nature. Okay. So acidic chemical properties, acidic character of alkynes. Acidic character of alkynes. Chemical properties. Chemical properties. First one is acidic character. acidic character due to the reaction of sodium and sodium amide. Sodium amide is a strong base. This is strong base. Okay. Then let's take ethyl. CH triple bond CH plus sodium, that gives CH triple bond C minus Na plus half H2 gas. As you know that the substance react with the metallic sodium liberate hydrogen, they are called acids. So here ethyl reacting with the sodium will liberate hydrogen gas. And one more hydrogen is here. CH triple bond C minus Na plus Na gives Na plus C minus triple bond C minus Na plus. This is monosodium ethanide. Monosodium ethanide. What about this? Disodium ethanide. Sodium means sodium. Okay. Sodium is shortly written as sod. Potassium POT pot. So disodium ethanide plus half H2 gas. What is the overall reaction? The overall reaction is CH triple bond CH plus 2Na gives Na plus C triple bond C minus Na plus half H2 plus half H2 gas. Clear? 2 moles of sodium. 2 moles of sodium reacting with 1 mole of ethyl, we get 1 mole of disodium ethanide and 1 mole of hydrogen. So this reaction reveals that alkynes have acidic nature. And another important is this ethyl CH triple bond CH react with 2 moles of NaH2 sodium amide. Okay, you can write it in as two step, no problem. First one molecule of sodium ethanide is formed. Then again 1 mole of sodium amide, we will get disodium ethanide. So I write in a single step. Okay, no need I write in 2 separate steps. Plus 1 sodium amide gives CH triple bond C minus Na plus NH3. The hydrogen is acidic nature. That hydrogen combines with NH2 to become NH3 and sodium is get attached to the carbonate. And what happens next? Okay, in the next, I write here, in the next, CH triple bond C minus Na plus react with 1 mole of sodium amide also. 1 mole of sodium amide. What we get? We get Na plus C minus triple bond C minus Na plus NH3. Disodium ethanide. Okay, so ethyl has 2 hydrogen, that's why 2 moles of sodium amide is required. What about the other alkynes? Let's take propyl. Okay, let's take propyl. CH3 C triple bond CH plus sodium amide. What we get? CH3 C triple bond C minus Na plus NH3. Okay, only 1 mole react because only 1 hydrogen. Okay, the terminal alkynes are acidic nature because it contains hydrogen actually. It's a very important thing. And the acidity order, next is acidity order. Acidity order of alkynes. acidity order of alkynes. Ethyne is more acidic than, propyne is more acidic than, sorry, butane, especially 2-butane. Okay, so here 2 hydrogen atoms. Here 1, here no. So the acidity order is in this order. Then what about the acidity order of alkenes and alkynes? It is quite different. Okay, the acidity order of alkenes and alkynes are more acidic than alkenes, CH2, double bond CH2, more acidic than CH3, CH3. So that's about the acidic nature. Alkynes are more acidic than, alkenes are more acidic than alkanes. Okay, so these are the important concepts. You go through it. Then other chemical properties we will discuss in the next section. Thank you.